Good afternoon, everyone. I want to apologize for getting this out a little bit late. I also want to apologize for missing class today. Had a few things come up, had to take care of them. Wasn't really anything I could put off, so I do apologize for that. But I do want to jump into the content. We're going to talk about Descriptive Analytics. It's where we describe the data, and in general, this is going to be the very first thing you would do when you're analyzing a large set of data. Okay, so you've probably done a lot of these in Excel. You looked at the mean, the median, and mode of stuff in Excel. You just use equals average, equals median, equals mode. Standard deviation for population or sample. We haven't really covered skewness or kurtosis much, but that's looking at the distributional shape of the data. All those are considered descriptive statistics. And in general, it's going to just describe the data. It's not providing any sort of information beyond this is what the data looks like. It's no prediction. It's just saying this is the data as we see it. Okay. So some common examples of this descriptive analytics would be stuff like sensitivity analysis. How sensitive is the data to change? What if analysis, as well as goal-seeking analysis. So all these are examples of decision support system. And the idea behind a decision support system is it provides evidence and some sort of a, I wouldn't say has to be quantitative support, but in general it's going to provide quantitative support for doing something. It doesn't make a decision for you, although there are certain types of decision support systems that do. A general DSS does not make a decision. Alright, it's also going to be used for stuff like data mining. So if you had a large amount of social media data, like Twitter posts is a common example of this, you can run it through some basic data mining algorithms, and you can do stuff like sentiment analysis. You could also do stuff like identifying historical patterns. You're not saying what to do about them, you're not predicting what will happen in the future, you're saying what's already happened in the data. So that's all about descriptive analytics. Okay, next we have predictive analytics, which this is going to be where we say, what do we think will actually happen? Okay, so we have some prediction, and this prediction is going to be growth or shrinkage. And we'll talk more about those terms as we cover the next class, which is going to be Wednesday. But in general, this is going to be also using data mining, only here we're actually predicting trends or behaviors. So we're predicting sales growth over the next 3 years. We're predicting whether or not something is fraudulent, those sorts of things. Also, this is where we get into regression analysis. So once you take I think it's some of the more advanced classes, you'll do basic regression modeling, where you have some predictors, and then you have, of course, your basic dependent variable. All right, and you're predicting that dependent variable using those predictors. So that's all you're doing there. And then lastly, forecasting. So not just looking at historic data, but looking at historic data to predict the future. That's predictive analytics. Okay, so some different types of forecasts. I'm going to go through these. Feel free to pause or slow this video down if you need to. But of course, we have naive forecasts. A naive forecast is simply going to be where we predict a future value based on the literal previous value. So if we had a data set that had, let's just say, 5, 10, 15, and 20, okay, we're not going to predict 25 for the next observation. We're going to, with naive forecasting, we're going to go back to the previous one, which is probably going to be 20, and that's what we're going to predict. Okay, simple moving average, we would take an average of almost in every context the 3 most recent observations. So in the context of 5, 10, 15, and 20, we take an average of course, 20, 15, and 10, which is, of course, going to give us 15. Weighted moving average is going to apply different weights to the different observations based on how most recent they are. And with this weighted moving average, all the weights must absolutely add up to 1. They cannot add to any less, they cannot add to any more. So if we had a data set of 5, 10, 15, and 20, we're trying to predict the 5th number there. We may use a weight where the first weight may be 0.5, second weight may be 0.3, the third weight may be 0.2. Okay, and what we do is we take 0.5 and multiply it by 20. That gives us 10. Okay, we would take the 0.3 and multiply it by 15. I'm not smart enough to do that in my head. Okay, but you get the idea. And then you add up those weights, and that gives you a moving average. Okay, don't get too caught up with it being an average. average because you're not using an average function for weighted moving average. Okay, the average is the fact that you're taking all the things and you're setting whatever weights you want and multiplying them. Okay, it contrasts with having completely equal weights that you're multiplying and then taking those, some of those residuals. Okay, so don't get caught up in that. Like I said, we'll do some examples of this next class, but I just want you to kind of understand the various formulas here. So some other weights you could use. You could use 0.7, 0.2, and 0.1. Okay, the weights will always be given to you in a problem, and they always must add to 1. Okay, that's a very vital concept here. So simple exponential smoothing, all you're doing here is you have some alpha coefficient. It's going to be between 0 and 1, including potentially 0 or 1. And what you're doing is you're taking the previous forecast, you're multiplying it by alpha, and then of course you're taking the previous observation, you're multiplying that by 1 minus alpha. So the key between weighted moving average and simple exponential smoothing, you're not multiplying by anything other than 1. Okay, because if it adds to 1, you're technically multiplying by 1. Anything more than that or anything less than that, you're changing, not multiplying by 1. You can always multiply by 1. Alright? So seasonality forecasting, this is where you're going to have seasonality coefficients. And the idea is that it's basically saying this percentage of the whatever season we're using, maybe we're using quarters, maybe we're using months, we're going to have some percentages. And I'm going to express them as decimals. So I'm going to take the total for the period, divide it out by and see how much of a particular season explains that. So if you add up all the seasonality coefficients, they must add to 1, or if you're using percentages, they must add to 100%. We'll do examples of this as well, so don't get too caught up on it. Okay? And then lastly, we have trend forecasting. So a trend in general is going to be a period of growth or shrink over a period of 1 to 3 years. So we're not just looking at something 1 year down the road, we're looking at between 1 and 3 years. Anything less than that would be seasonality. Okay? Anything more than that would be cycle, a business cycle. Okay, so you're looking at period from recession to recession, that's going to be a business cycle. You're looking at a period of 1 to 3 years, that's going to be a trend. And all you're doing is you're predicting the growth or shrinkage. So we'll do examples of all of these. Don't get too caught up on them for now. I just want to introduce them. The last major type of analytics is prescriptive analytics. So here we're actually recommending some action. You go to a physician, you describe your symptoms, okay, they give you a prescription. It's the same thing here. So think about a driverless car. Alright, here, identify is talking about the descriptive analytics. Okay, predict is talking about predictive analytics. We're in both decide and execute here. Okay, so when you're driving, you're constantly identifying. You're predicting what's going to happen. You see a cyclist on the road. You predict they're going to stay on their path. Hopefully they do. You decide what to do about it. Maybe you give them a couple feet. Maybe you, well, that's probably the only answer I'll say here. Anyway, okay, so you decide what to do and then you execute. You actually do it. Alright, so this is most commonly going to be used in like supply chain analysis, where you're prescribing some action based upon what the analysis suggests, okay? So this is where you actually would go forth and take the action. Alright, just to wrap everything up, we covered the managers and the decision-making process, as well as the business analytic process, the 3 major types of analytics, which just to remind you, are going to be descriptive, predictive, and prescriptive. And we also talked about presentation tools. So I do want to apologize again for missing class today. I did go ahead and extend the lab 2 to be due on the 16th instead of due today. I wasn't on campus today. I was not at an office hour. I do sincerely apologize for that. I will be on campus tomorrow. So if you want to attend that office hour, I believe it is 8 a.m. until 9:15 a.m. I'll also be available before and after class, as well as other office hours, of course. So just want to apologize again. Hope you all have a great Valentine's Day, and I hope to see you all Wednesday.